Okay, so now we're going to have a look at another one so we can practice. So a cafe keeps track of percentage of people who purchase hot food and cold food. On the first day, so when they tell you this on the first day, they're telling you your SO, your first state, okay? So they said there was 400 hot meals and 500 cold. So it's always good, even though they've written it down there, we need to write which one's which. So let's write, they've done hot on top and cold. So if you were reading your transition matrix, you need to make sure that you've got that there. Now, it's asked me to predict how many people choose hot and cold after 1 day or after 3 days. So for us to get those answers, we'll need to use this, first of all, we need to find S1. So let's find S1. So we can just, you don't have to write all the numbers out. You can just write the coding. So we're going to say we can find S1 by going T times SO. And then we'll do that on our calculator. So over here you can see, no, I don't, wait a minute, let me, I'm just trying to find it. Okay, let's not go, so let's try and work, we'll just get it set up ourselves. So to get a transition matrix, there we go, I've picked the square one. I'm gonna pop in the numbers. All right, so there's my transition. Sometimes it's easier, sometimes it's easier just to set your transition up and then just press enter and it's floating over there so you can grab it later. And then I'm gonna set up my SO. So we've got some quick keys to get a 2x1. So boys, just remember this is recording. Okay, so we're going to get, if we look up here, so we're going to do the transition times the SO and press enter. So here we go. S1 ends up being 560 and 340. Now for us at the moment, to get to S3, I need to use S2 because we need to use the one before. So I'm going to step it up and first I'm going to find out what S2 is. So once again, all I have to do is I'm actually putting this answer into there. So let's do that on the calc. So I'm just going to highlight what I did before and I'm just going to edit this. We now have 560 on the top and we have 340 on the bottom. So we click on that and we end up with 640 and 260. So this is S2, this was S1. So I needed to find S3 as well. So it'd be the transition times S2. Now you have to show all your working out like that. So everything that I show on this paper, this is what you should be showing in your workbooks when you're working it out. So yes, you will. So in year 12, unless you're showing, yes.
Sorry, you can see the first part, yep, S3, T,
yep,
like that.
Yep. So if you write everything that I'm writing there. So we pop that one in, 640, 260, we end up with 680 and 220. Okay, so now we want to write the answers because it said how many people are hot and cold. So after 1 day, we might just write this answer up here. After 1 day, we're going to say 560 for hot and 340 for cold. Okay, and then we'll write down here, after 3 days, we have 680 for hot and 220 for cold. You have to make a separate statement to show that you're working that out properly. All right, so we're seeing how we can find the next state by using the one before. But what happens is, say I've got this is like, at the canteen and this is daily, and they might, or a shop, and they want to know what's going to happen after 30 days. After 1 month, how many people are we going to have, or so on. So that's going to get annoying if we have to start at the start and keep going. So what we have is we can create this rule. It's an nth rule. So this is a rule where we can use this to find any state. So use this to find any state, and with SO. So as long as we've got the original state, we can find the next one. So what we want to see, and often you'll hear, we call this like the power trick. So, and what we want to see, if, say this, for example, under here, this is the state you want. So this is the number you want, okay? So if you want, say 20, what you want to know is the number that you raise this transition to a power to, and this number, so at the moment it's always going to be O. If these two numbers, so if these two numbers add up to what you want, then you can get it. So say, I'll show you in a minute. So these two numbers should add, so to give the number you want. So what we mean by that, so for example, if I say I wanted state 20, what I can do the transition to the power of 20 times state 0. Now, can you look, does this number 20 and 0, does that give this? It does, doesn't it? 20 plus 0 is still 20. So that would give you the answer. Now, see how transition, we're raising that to a power. We can only raise square matrices to a power. Is a transition a square matrix? It is, isn't it? A transition is always square. Okay, so if you wanted, say for example, I wanted state 5, and you will always be given the transition, but what if I only got given state 2? What could I raise that transition to so that the numbers would add up to 5? 3, good. So see how that we can say that this 3 plus this 2 gives 5. So really, the power trick means you can get anyone as long as you have a state. So as long as they tell you one of the states, normally for you guys, it's going to be a lot of the time it's the initial, it's SO. So, but just so you know that you can always go ahead. All right, so let's go. I'm going to pause it for a bit and I'll let you guys let's see if you can do the start bit of this. Okay, so with this one, it said a study was investigated and it changed in the change of population at Geelong and Ballarat due to people moving between the two cities. So at the start of the study, the populations were 250 at Geelong and, the populations at Geelong and Ballarat were 250,000 and 110,000 people. So when they say respectively, that means whichever one they said first is the first one there. So now I know that this top number is Geelong and this bottom number is Ballarat. If I look at it, I also know that the total population is 360,000. So you should never lose any people. So your states should always add up. So here, when it says, so here's my beginning state. Now it says the transition that can be used to chart the population between the two cities from year to year. When they tell you that, that means the state is year to year. Before it was day to day. So the state, so this is telling you the states are year to year. So that means S1 is after 1 year, S2 is after 2 years, and so on. So they've given you the transition and you've been told that. So we need to know that this is G and B and G and B down that way. Okay, now the first question says using recursion. So in year 12, they will ask you that. They will say using recursion or show recursively to predict the population of Geelong after 1 year. So because you have to, you must show it all you're working out. So you've got to find after 1 year, which is S1. So 1 year was state 1. The way we find state 1 is the transition times the one before. Now, you can use the letters because up here, they defined it, didn't they? They said T was that. So that's okay. You don't have to write all the numbers out. Now, if you did that on your calculator, you would have ended up with 241500 and 118500. Now, that's telling me we know the top number is Geelong and the bottom number is Ballarat. Now, they asked you to say what was in Geelong. So you need to also now write a statement so that you know, that you demonstrate that you know. So 241 at Geelong. That's okay if you just do it like that. Okay, so then part B, they said they wanted the populations after 2, 3, and 4 years, but they said using recursion. So I'm going to have to show the working out. So that means I have to show the formula I've used. Now, recursively means you use the one before. So that's all. I have to keep showing that. So if we do that, we get these numbers. Okay, so I'm just going to pause it Alright, so it asks us after 2, 3, and 4 years. So I'm just always stating the top number because that's the Geelong. So after 2 years, so if we say after 2 years, we had 235 at Geelong. Then after 3 years, we had, now I'm going to round to a whole number because we're talking about people. So I'll just round to the nearest whole number there. So I'm going to say there was 200. It doesn't matter if you don't, because when you're making a prediction, you can have decimals, but that's okay. We'll round it. And then the last one, after 4 years, we've got 226. Now, when you do recursively, obviously it takes a long time to keep going through. So they generally, in a year 12 exam, they only make you do maybe two goes. Here we had to do 3 times maybe. So it wasn't, you don't get asked to do too many. Now, even in part C, if we go on, it says using the SN rule. So that's like the end term rule. So it says work out the population after 20, 30, and 40 years. So what I'm going to do to find S20, they gave me the transition and they also gave me SO. So I'm going to use their numbers and I'm going to use it to the power of 20 and I would find it. And then because they've asked me for 30, S of 30, I'll do the same. Transition to the power of 30 times SO. And then S40 would be the transition to the power of 40 times the SO. So we'll do them in a minute. You can write out the answers. So we were using that power trick and to find, and we saw after 20 years, Geelong had 216 and 108. Then after 30, then after 40. So what did you notice? We can notice as it's slowing down and it's starting to always be close to 216 at Geelong. So this is what happens after so many transitions. You hit what we call a steady state or the long term. And so that's probably what they're looking for, because they know, all right, in the long term, we are going to have this many people at Geelong and this one at Ballarat. So they might, for like infrastructure design and things like that, they go, right, we're going to need this and whatever. And so governments may use that. So